Example 4, what effect does doubling the diameter of a circle have on the area of the circle? So again, we're going to use kind of the same one we used in the last lesson. But we're going to say that this diameter, okay, we'll say that that diameter is 2, and this diameter is 4. We want to know what effect that has on the area of the circle. Okay, well we know the area is pi times r squared. So we need to know how much the radius is. Well, if the diameter is 2, then that means my radius of the circle has to be 1. Okay, we need the radius. That means the radius of this circle has to be 2, because the radius is always half the diameter. So when we plug these into the formula, we're going to make sure we use the radius and not the diameter, because that's what the formula asks for. So my area is pi times my radius, which is 1, squared. Well, that is pi times, and 1 squared is 1. So basically, our area for this circle equals pi, or 1 pi. Then over here, we get pi, or area equals pi times our radius squared. And our radius in this case was 2 because our diameter was 4. Do the exponent first, we get pi times 2 squared is 4. So my area equals 4 pi. Okay? Well, what happened? When we doubled the diameter, look what happened to our areas. We went from 1 pi to 4 pi. So it multiplied by 4, or quadrupled. Okay? So we can say that the area quadrupled. Or if we don't know that word, or multiplied by 4. Okay? So quadrupled means the same thing as multiplied by 4. When we double the double the diameter of the circle, our area quadruples. Okay? Let's go on to our last couple examples. Alright, we have two definitions here that we need to know. First one is a sector. A sector is a part of a circle enclosed by, sorry, this should say, man, bad grammar here, by 2 radii and an arc. Okay, so pretend here's the center of our circle. So here's a radii, and here's another radii, and then this right here is an arc. Okay, the distance between those. So this right here is a sector. All this stuff in the middle there is a sector. Okay, and we'll actually just use lines to tell that's what we're looking at. Okay, so the sector is kind of like a piece of pie. Alright? A central angle is the angle formed by the radii. Okay, and that determines the fraction of the area of the circle the sector occupies. So, if I look at 2 other radii, then this angle right here is called the central angle. So every sector has a central angle right here, formed by 2 radii. Okay, so that's what that means. So let's say that this central angle was 60 degrees. Okay, then that means that this sector is 1/6 of the circle, because the circle is 360 degrees total. Alright, let's move on to the last example. Alright, so find the area of each sector and express in terms of pi. So again, we get to leave our answer in terms of pi here. Okay, well, first thing we need to do before we can find the area of the sector is find the area of the whole circle. Okay, so the area of the whole circle is, again, pi times r squared. Well, they're telling us here our radius is 4, so we're going to take pi times 4 squared, which means 4 squared is 16, so it's pi times 16. So the area of the whole thing is 16 pi. Okay? But we only want to know the area of this little piece right here. Okay? So what we just found was the area of the whole circle. Oops, circle. There we go. Okay? So the area of the whole circle there. Well, to find the area of the sector, we're going to figure out what fraction of our whole circle this sector is. So the central angle is 45 degrees. So 45 degrees out of 360 degrees, we need to figure out what that is. Well, 45 divided by 9 is 5. Okay? And 360 divided by 9 is 40. So that reduces down to 1/8. Okay? So our sector is 1/8 of the circle. Well, if the sector is 1/8 of the circle, then that means the area of it is 1/8 of our area we got. So we are going to take, 1/8 of 16 pi. Well, 1/8 of 16 is just 2. Okay, so that equals 2 pi. So the area of our sector is 2 pi because it was 1/8 of the entire circle. Okay? Now, make sure you have all this stuff down here written down. Okay? All this. Because I'm going to have to erase it to move my screen back up. Because otherwise it's going to go like this. And that doesn't look very nice. Okay? So make sure you got all this stuff written down. If you don't, pause it. But I'm going to go ahead and erase it. Okay? We're going to go ahead and get rid of all this stuff down here. Alright, now we can move my screen back up. Okay, so again, we're finding the area of each sector, and it says expressed in terms of pi for B. Well, we're going to pretend like this is the whole circle here, and this is 16 centimeters across. Okay, well, the first thing we need to know is the radius. Well, if the whole thing is 16 centimeters, that's the diameter, then our radius has to be half of that, so it's 8 centimeters. So we use our area formula, our pi times r squared. We know that our radius is 8, so it's 8, or area equals pi times 8 squared. And 8 squared is 64, so it's pi times 64, or the area equals 64 pi. Well, if you look at this picture, this is a semicircle. Okay, compared to our whole picture here, this is half of that. So our area of our sector is going to be half of our area here. So again, we look at this answer. This was the area of our whole circle. So the area of the sector is going to be half of 64 pi. Well, half of 64 is 32. So it's just 32 pi. Okay? Oh, and we need to make sure we put centimeters here. And I guess on the one before that I put, this example over here that I erased, go back and label your answer with centimeters squared. Okay? Should be centimeters squared for area. So 32 pi centimeters squared. Alright, that's it for the video. Good luck on your homework. Make sure if you have any questions that you ask them. Okay? And make sure that we really are focusing on the difference between the area formula and the circumference formula for circles. Alright, otherwise, best of luck.